Okay, ladies and gentlemen, this is a video. Obviously, I decided to go ahead and start making some more videos. And sorry for my mumbling here. Haven't done this in a while. But anyways, this is video number 101. I thought I'd start a new series of videos. I thought I'd start with number 101 to keep it separate from my other videos. And hopefully, you've seen some of my videos before and thought they were productive. But long story short, I do have hundreds of videos on Novi Math Stars and Novi Math on YouTube. So please keep that in mind as you watch this video. But anyways, the thing I want to talk about, as the title says here, is transformations and functions a little bit. Now this is not going to have everything in it, but I'm going to focus on a few key things that I know are going to help you. So here we go. As you can see here, guys, we have a nice curvy function. And whenever you see a function that does something like that, you should realize that it is a cubic function. Alright? A cubic function. Okay? And as you can see, I could figure out very easily that -3 makes that 0. -1 makes that 0. +2 makes that 0. And right there, and there is -3, 1, and 2. Okay, and that's why we call them zeros. Zeros or roots. R-O-T-S, roots. Or, as they are shown as, x-intercepts. Okay? But that's actually not what I wanted to talk about today, but I just thought I'd throw that out there since it's right in front of us. So I'm just going to back up here a little bit. Again, if I just happen to erase something you want to write down, feel free to pause or rewind or whatever the video. But anyways, here's what I really wanted to talk about in particular is one thing now that you get into trig pre-calc, or what we call in my school integrated math 3, is you actually start not only graphing all these different functions, but you have to start really analyzing and understand what the function is doing. For example, I hope you notice right there and right down here are some what we call maximum and minimum points. And the one thing you have to get comfortable with, let me be a little bit neater here, but as you can see, that right there is the highest value within most of the shape here, right? It's kind of like a peak within the curve, correct? And so that's where we get the name maximum from. Okay, that's where we get the name. It's a maximum, relative maximum, we say. Relative. Why does it have a hard time writing here? Relative maximum. Let me try that again. So, relative maximum. Relative maximum. Obviously need to start working on my writing some, but hopefully it's legible enough. But anyways, and likewise, down below here, I'll use purple. That point right there is called a relative minimum. Relative minimum. Okay? And one thing you have to get comfortable with is approximating more. Notice how the maximum, let's go back up here to this maximum, is not an exact whole number value. So you have to get used to estimating. Notice it's a little bit past -2 there, isn't it? So we're going to say that point is -2.2, let's say. You could say -2.1 maybe. And it is really basically at that value right there, which is 3, correct? See, 1, 2, 3, no, 4. Stand corrected. So does everyone agree my relative maximum is -2.24? Likewise, follow the red down here. Notice how it's a little bit short of 1. So I'm going to approximate that as 0.7. And it does go down a little bit below, looks like. Let me just count to make sure. 1, 2, 3, 4, 5, 6, 7. So if I counted correctly, it goes a little bit below -8. So we'll just say -8.2. Now if you said -8.3 or -8.1, your teacher most likely will give you full credit. But the bottom line is, you're just going to have to get used to approximating things more. Okay? So pause the video if you need to. And there's one more thing I wanted to do really quick here. One more thing I wanted to talk about. I promise you I'm almost done. Okay? Is not only should you be familiar with max and mins, but also increasing and decreasing. So follow the red here, for instance. Notice from all the way down here, and notice how it goes down forever, right? So that would be -infinity. It's like a racetrack symbol, figure 8 symbol sideways, right? So it's going down to -infinity, and all the way up to that maximum right there. And again, I believe we use -2.2 for that, right? Well, that's what I'll use this time anyways. So notice from -infinity to -2.2, it's going up, isn't it? From there to there, it's going up. Remember, always read from left to right. And likewise, from the minimum, it goes up to +infinity, we say. Okay? And again, what do they call that value there for x? 0.7, right? So I know from 0.7 to +infinity, and that's how we show it with parentheses like intervals, guys, is where it is increasing, okay? So again, from -infinity to -2.2 for x, do you agree? Right in here, it's going up. Likewise, from 0.7 for x up to +infinity is increasing as well. And in those two intervals, it is increasing. Notice, follow the green, right in between them is where the value or the shape or the function is going down, right? Remember, always read from the left point to the right point, which is way below it here. And so we would say from, what was it, -2.2 for x up to 0.7 for x, it was decreasing. Okay, now pause the video again if you need to. Alright, so guys, this is basically the end of my first video. And I just want to make sure you focus on a couple things. First of all, know how to do the interval notation. Does it make sense to you? Understand you are going to approximate a lot more with your graphs. You have no choice. And understand when it's increasing, when it's decreasing. And of course, what did I start out with really is my maximum and my minimum values. Please watch this video again, rewind it, pause it when you need to. Okay? Make sure you understand everything I talked about in this video. Until next time, bye.